Hello, welcome to Pre-Cal Lecture 4.2, where we're going to talk about properties of exponents, and we're going to solve for exponents. We've got some pre-printed notes here, and we're going to do a lot of example problems. So first of all, reviewing the properties of exponents, I've got all the important properties listed. We've gone over these before in prior sections. So I'm not gonna go through them again, but you do need to have all of these memorized, and you probably already do. So the second bullet says steps for solving exponential functions. We want to use the properties of exponents. So we're going to use these properties to write each side of the equation as a power with a common base. So we need the same base on both sides, and then we can set the expressions in the exponents equal and solve. Okay, so I'm going to do a lot of examples, probably too many examples to fit just on this front of the page, so feel free to go flip over to the back and take notes on the back. So for the rest of this lecture 4.2, it's all just example problems. So our first example is we want to solve for x on all of these. 2 to the x is equal to 4. Now, I know that's really easy, but I want to show you how we're going to solve all these problems. We need a common base. So I'm going to rewrite 4 as 2 squared. Now we have a common base of 2, and I can set the exponents equal to each other. So once you have a common base, we can set exponents equal. All right, so x equals 2, right? X equals 2. The exponents, we set those equal to each other. Okay, so all of these, the instructions are to solve for x. So let's say we have 8 to the x is equal to 2. Well, I need a common base. I can't really do anything with the 2, but I could rewrite an 8 as 2 to the third power. Now we have to the x, you can't forget about to the x, is equal to 2, and I want to rewrite that 2 as 2 to the first power because we need to have exponents on both sides. So when you raise a power to a power, you multiply those powers. So 2 to the third to the x, that's the same as 2 to the 3x. Multiply those exponents. Now we can set the exponents equal. So we just have 3x equals 1. So x would be, divide both sides by 3, 1/3. All right, so not too bad at all. I think I can fit the next one on here. Let's say we have 8 to the x is equal to 4. All right, well, how about we try writing both of these in terms of a base of 2? Because that's a pretty easy thing to do for both 8 and 4. So 8 is just 2 cubed to the x power, and 4 is 2 squared. So that's going to be 2 to the 3x, after we multiply the exponents, is equal to 2 squared. We're going to set those exponents equal. 3x is equal to 2. So divide both sides by 3. X would be 2/3. Okay, and then you can test that. You can put it in your calculator. What is 8 to the 2/3? Well, it's the cube root of 8. Cube root of 8 is 2, and then 2 squared is 4. All right. So we can make them more fancy than that, the examples, and but we want to start out as usual. We want to start out pretty easy. So let's raise the game just a little bit here. Let's say we have 1/3 to the x power is equal to 27. Well, I'm looking at that and I'm thinking, well, I'm not sure what to do here, but I know that 27 we can write in terms of a base of 3. 3 cubed is 27. So could I somehow manipulate this 1/3 into a base of 3? Well, I could use this property, a over b to the minus x is equal to b over a to the x. I could flip 1/3 and it's just 3 to the negative x. And I could write 27 as 3 cubed. Now we have the same base. We can set the exponents equal. Negative x equals 3. So divide both sides by -1. X equals -3. So we kind of used a manipulation technique to our advantage there to solve that equation. Now, if you need to flip, if you don't have any more room on the front, just flip over to the back. And each example will get a little more fancy. So let's say we have 4 to the 2x plus 1, all as the exponent, is equal to 64. Well, what common base could we use here? Well, you know, you're going to need to know some of your common bases, or, you know, you could try to figure it out with your calculator. But 4, I can actually rewrite 64 as 4 cubed. 4 times 4 times 4 is 64. Now we have a common base, and I can set the exponents equal. 2x plus 1 is equal to 3. So subtract 1 from both sides. 2x is equal to 2. So x is equal to 1. All right, let's try to shoehorn in one more before I erase. Let's say we have 3/5 to the x plus 7 is equal to 9 over 25. So could I rewrite 9 over 25 in a way that would give me a common base? How about we try to rewrite 9 over 25 as 3/5 as the base? So we have 3/5 to the x plus 7 is equal to 3/5 squared. All right, 3 squared is 9, 5 squared is 25, so those two are the same thing. Now we can set the exponents equal. X plus 7 is equal to 2. So subtract 7 from both sides, and x is equal to -5. That's kind of fun, isn't it? It's kind of like a puzzle. How can I get a common base? All right. So let's do one more. Let's say we have 27 to the x plus 2 is equal to 81 to the 1 minus x. Well, what you need to recognize is that 27 and 81 can be rewritten as bases of 3. So 27 is 3 cubed. So I can rewrite that as 3 cubed to the x plus 2. 81 is 3 to the 4th. If you're not sure, just check it. To the 1 minus x. Now, we multiply 3 times x plus 2. Okay, so that's 3 to the 3x plus 6. Remember, you have to distribute the 3 across both. I have seen so many times students write that as 3x plus 2, but it's 3x plus 6 is equal to 3 to the 4 times 1 minus x would be 4 minus 4x. You have to distribute that 4 across both of those. I've seen students write that as 4 minus x many times. And now we've got a common base, so we can set the exponents equal to each other to solve. 3x plus 6 is equal to 4 minus 4x. Let's move that negative 4x to the left, adding it. That'd be 7x. Subtract 6 from both sides. 4 minus 6 would be -2. So x is -2 over 7. That's probably not one. That would be easy to solve in your head. But with this manipulation technique, pretty easy to solve. So your homework is going to be worksheet 4.2-4.3, 1 through 6. Okay, the last 6 cover section 4.3. So I don't know if you will be, depends on when you watch this, as if you will get the whole worksheet at once or you will just get 1 through 6. Just a few things to remember that might help you. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. You know, learning those would be really helpful. 3 squared is 9. 3 cubed is 27. 3 to the 4th power is 81. 4 squared is 16. 4 cubed is 64. So these are just kind of some of the simpler ones that will help you do this kind of homework. 5 squared is 25. 5 cubed is 125. That should cover most everything that you would have to do. And of course you can use your calculator to figure this out, but you know, if you have those memorized, it will help you on this assignment. So that does it for this lecture. Nice short one. I'll talk to you on the next one.